Alright, welcome back. This is the second video of 1.4's discussion. We're picking up on 18, which is a complex fraction. So I have a bunch of yuck divided by a bunch of yuck, right? What I really want is just a single fraction divided by a single fraction, because if I have just a fraction over a fraction, I can flip it, turn it into multiply, simplify, and life gets easier. So, in order to get a simple fraction, what I need to do is turn this x into a fraction by, I'm just going to erase it right here and just call it x over 1. I'll do the same thing in the denominator because that's next, right? In order to combine these two fractions into a single fraction, I need a common denominator, and that denominator is x plus 3. So I'm going to multiply both sides by x plus 3. Right? And I'll do the same thing here because, well, that's going to happen sooner or later. Right? So if I clean this up a little bit, in this x gets distributed through, and that becomes x squared plus 3x. Over the common denominator here of x plus 3, so I'm going to combine my entire numerator and just call it all of that over x plus 3. So I have a simple, well, I don't know, simple's maybe a bad word here, but I have a fraction, right? I have a numerator, a denominator, I have a fraction, a rational expression. I'll do the same thing here. I get x squared plus 3x. And then I tack on this minus 2. And now all of that's over x plus 3. Okay. So I have this big jumbled mess of yuck, but it's still a fraction being divided by a fraction, so I can take this bottom fraction, flip it, and call this multiplication. So I'll rewrite this here. X squared plus 3x plus 1 all over x plus 3 multiplied by x plus 3 over x squared plus 3x minus 2. Right? I've just taken the denominator, flipped it, and turned it into a multiply. The nice thing I can see right off the bat, my factor of x plus 3 is going to cancel out. Let's see what my numerator and my denominator that are left factor into. This top one doesn't factor, because there's no factors of 1 that'll give me 3, and the bottom one will also not factor, and I'm done. And all it is then is this numerator, which is x squared plus 3x plus 1, divided by x squared plus 3x minus 2. Done. Good. Okay. Let's look at 19. 19 is y over x minus x over y all over 1 over x squared minus 1 over y squared. Yep. So it's kind of the same idea. I want to turn my numerator into something with a common denominator, that is, that it has to have an x and a y. So I'm just going to multiply my left one by y to give my denominator the xy, and I'll multiply the right one by x to give my denominator the xy. They both have the denominator of xy, and so now I have y squared minus x squared over the common denominator, so I'm going to combine it into a single fraction over that denominator of xy. In the denominator here, my common denominator has to have an x squared and a y squared, so I'll multiply this one by y squared, and this one by x squared. That gives me a y squared over x squared y squared, and minus an x squared. So I'll combine that into a single fraction because they are over the same denominator now. Once again though, I've taken it down into a fraction over a fraction, right? A simple, so to speak, fraction over another simple fraction. They're not simple, they're ugly, but it's a fraction. It's just a fraction over a fraction. That's what we're looking for. Which means I can take, and maybe you should stop sticking my fingers all over everything, flip the bottom one and turn this into a multiply. So this becomes y squared minus x squared over xy multiplied by x squared y squared alright, this bottom one flipped, y squared minus x squared. But you can see this y squared minus x squared is a factor in the denominator, it's a factor in the numerator, it's gone. See ya, take a hike. An x in the denominator simplifies with a factor of x in the numerator, as does a y. So the x cancels one of the x's, leaving the other one. A y cancels one of the y's, leaving the other one. And I boil down to xy, and that's it. Good. Alright, let's take a look at, there's two more here we're going to look at. We're going to look at 21 and 22. 21 says rationalize the denominator. And I have 3 over 5 minus root 10, right? And we should have seen in the videos and some of the homework, if you have something like, say, 2 over root 5, I would just multiply top and bottom here by root 5, because root 5 times root 5 is 5. It's no longer irrational, it's a rational number. These two are, this thing is its own conjugate. But when I have a number that has both a rational part and an irrational part, then I have to play with it a little bit. That conjugate is the same number except with a plus. I'm going to just change the sign between the two of these things. And so I'm going to go 5 plus the square root of 10 and see what happens. But of course I have to do that top and bottom. The top isn't too hard because the 3 just gets distributed, so that's 3 times 5 is 15, plus 3 root 10. The top can be irrational all we want, we just want the denominator to be rationalized. Right? But what happens here is that I've got two essentially binomials being multiplied to each other, so I'm going to FOIL. 5 times 5 is 25. 5 times the square root of 10 is 5 root 10. And then I have 5 times the negative root 10, so that's minus 5 root 10. And then the negative root 10 times a positive root 10 is just minus 10. Right? And this is where the magic happens, because I have the same number, but one's positive and one's negative, so they cancel each other out, and they are 0. 25 minus 10 is 15, right? And I actually did myself a disservice by taking this 3 and distributing it through, right? I'm going to erase this work for a second and show you why. And by for a second, I mean forever. But if I leave it as a 3 on the outside, and then a 5 plus root 10 on the inside, over that 15, it's easy to see that a factor of 3 and a factor of 15 can simplify. I don't want to see you come over here and say, oh, the 15s cancel. No, because now you're 100% wrong and you lose points on your test. Don't do that. They don't cancel unless they're factors. You can't cancel something that's part of a sum with something in the denominator. It has to be factored out. This 3 can simplify, leaving you with a 5. Do not try to cancel that 5 with that 5, because that 5 is part of a sum. You can't do it. And so I end up with 5 plus root 10 over 5. I can't simplify it. Be done there. Don't hurt yourself by trying to do more than you are able to do. That's our answer. last one I'll do here is number 22. And it says, similar, rationalize the denominator, but here I have two irrational parts. I have the square root of 2 plus the square root of 7. But it's the same kind of setup. I'm going to multiply the left by root 2 minus root 7. And then of course the same thing in the numerator. So the numerator is easy, that 5 just gets distributed or not, whichever. Let's just leave it not distributed because it might be advantageous not to distribute it. But in the denominator, I'm going to get root 2 times root 2, which is 2. The square root of 2 times the negative square root of 7 is a minus square root of 14. But then I get the positive root of 14 after that one. And then root 7 times negative root 7 is just minus 7. The root 14s cancel each other out, and I'm no longer irrational in my denominator. I just have 2 minus 7, which is negative 5. And therefore it's nice that I didn't distribute the 5, because the 5s will just cancel out. This negative though, the only thing I have left in here is a negative 1 if you will, in the denominator, so throw it up, right? Just take this guy, put it up here, and then distribute it through. That gives you negative root 2 plus root 7, which they might have as the square root of 7 minus the square root of 2. Either one of those, and it looks like the answer is this one. Alright, so this was a bit of a longer video. Keep up the good work though, you guys are going through, you're doing well with everything that we're doing, so I will see you guys on the next one.